So now we are going to start one of the very important portion of higher mathematics, which is known as the part vector integration. And particularly for GATE exam, it is very much important portion, and two questions on an average, 2 to 3 question every year they ask from this part of vector integration. Here are some theorems like divergence theorem, then you have Stokes theorem, and you have Green's theorem. These three theorems are there, and they are nothing but the relation between your volume integral with surface integral, surface to line integral. Okay, how we will see all these things when we discuss all the theorems very elaborately. Okay, so first of all, when we talk about volume integral, correct, volume integral, that means you have this sort of integral. Okay, this is nothing but volume integral. Suppose you have this fellow and dx dy dz, this is your volume integral. Okay, so this is your volume integral. When we talk about surface integral, it is nothing but this. Over a surface you need to integrate dx dy, or it may be dy dz. Okay, this is your surface integral, and here you have the line integral, that means single integral. Okay, so it is dx. Okay, so this is line integral. All right, so when we talk about volume integral to surface integral, or the relation between volume integral with surface integral, in that case you have divergence theorem. In that case the pull is there as divergence theorem, this first fellow. Okay, when we talk about the relation between surface integral with line integral, in that case we have Stokes theorem. So this is Stokes theorem. Okay, and particular case for Stokes theorem, it is known as Green's theorem, which is nothing but a particular or special case of your Stokes theorem. All right, fine. So let's see how they are related and what are the theorems. So we will discuss all the things elaborately now. Okay, so first one, it is your divergence theorem. All right, so for that purpose, suppose you have a volume. So this is your volume. Okay, solid body, and its volume is V. Okay, surface, it is bounded by the surface S. All right, and say n is the outward unit vector. So this is unit vector, outward unit vector, which is nothing but n. So outward unit vector, say this is n. All right, okay, so with this construction, suppose let a be a vector point function, then this divergence theorem says that this volume integral over this V, okay, this volume integral, that is this divergence of this vector A dV is going to be equal with the surface integral, this surface integral a dot this unit vector n ds. Okay, so over this surface S. Okay, so this is your divergence theorem, or this fellow here in the right part, you can simply write it like this way: over this S, a vector dot ds vector. Okay, so that means n vector ds, you can simply write it like this way. Okay, fine. So this is nothing but a relationship between this volume integral with the surface integral, and it is given by this divergence theorem. So you should remember this part. Okay, because in the exam hall frequently they ask question related to divergence theorem. Okay, so this one, it is nothing but the quantity, it is divergence of a vector dv. Okay, here you have the triple integral which is equal with this surface integral. All right, so this is your divergence theorem. Now another portion which is known as Stokes theorem. So Stokes theorem. For the Stokes theorem, you have the same formation is there. Suppose A is a vector point function. Okay, and you know your r vector, which is, suppose you have dx I vector plus dy j vector in 2D, you have this, and if you are considering 3D, then this is going to be dz k vector. Okay, so this, all these formations are there, and suppose the boundary of the region you are considering as C. Okay, the boundary is C, or the bounding curve. You are considering the surface S, volume V, surface S, volume V, all these things are there, and the bounding curve, it is given by C. Okay, in that case, whatever your Stokes theorem it is, it says that the surface integral curl of this fellow dot n vector ds, it is nothing but this line integral a dot dr. Okay, so it is relationship with the surface integral to the line integral. This one is line integral and this one is nothing but your surface integral. So look at here, this quantity, it is nothing but the curl of the vector A. So curl vector, that is curl vector, it is dot product with ds vector, or you can simply write this ds vector as the outward unit normal vector n ds. Okay, and that is equal with a vector dot dr vector over this bounding curve. All right, so you have to basically remember this formula as well, which is Stokes theorem. All right, okay, with this understanding of Stokes theorem, we have a particular case of Stokes theorem which is known as Green's theorem. In fact, this is an exercise. One can easily show that this Green's theorem, it is nothing but a special case of Stokes theorem. So in that Green's theorem, all the formulations are same, and whatever region you are considering, say this region you are considering, bounding curve, it is nothing but C, bounding curve is C, and this area, so this area, it is given by R. Okay, so in that case, suppose you have this quantity m dx plus n dy, where this m, n, these are function of xy, and these are continuous function over this bounding curve C inside and on. Okay, in that case, this is equal with this integral del n del x minus del m del y dx dy over this r. Okay, so this is your Green's theorem, and Green's theorem, it is relationship between this line integral with the surface integral. In fact, whatever surface we are considering, the bounding region, it is r here we are denoting. Okay, so these are basic theorems, and one need to know the formula of Stokes theorem, Green's theorem, and earlier the divergence theorem, and after that you can easily use these theorems to solve problems. Various kinds of problems are there, and in the next video we are going to solve some of the problems. Stay tuned for that video and meet you soon in the next video. Bye.